Hello, 6th graders. Welcome to Big Ideas Math, Contract Math, Section 9.2, 2012 edition, Theoretical Probability Lesson. Pause while you write Section 9.2, 2012 edition lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is compute the theoretical probability of an event. Copy the following key terms, definitions, and examples exactly as they appear into your notebook. Theoretical probability. The ratio of the number of favorable outcomes to the number of possible outcomes when all possible outcomes are equally likely. Fair experiment. A fair experiment is an experiment in which all of the possible outcomes are equally likely. Today we'll be beginning on page 392 in your math textbook. Example 1, finding a theoretical probability. You randomly choose one of the letters shown. So these are the letters they're talking about. What is the theoretical probability of choosing a vowel? P is the event, so that's the probability of the event, equals the number of favorable outcomes. So in this case, that's choosing a vowel. So the favorable outcome is the outcome that you're interested in. So that's choosing a vowel. And you divide that by the number of possible outcomes. So the probability of choosing a vowel equals 3 divided by 7, or 3 out of 7, because there are 3 vowels in a total of 7 letters. So the probability of choosing a vowel is 3/7, or about 43%. And we get that 43% by dividing 3 by 7. Example 2, using a theoretical probability. The theoretical probability that you randomly choose a green marble from a bag is 3 out of 8. There are 40 marbles in the bag. How many are green? So the probability of green equals the number of green marbles out of the number of total marbles. So 3 out of 8 equals the number of green over 40. So we substituted in all of the things that we knew, because we knew that the probability was 3 out of 8, and we knew that the total number of marbles in the bag was 40. The thing we don't know is n, so we put n in for green marbles. And then all we do is we multiply each side by 40 to make n be by itself, and when we do that, we get 15 equals n. So there are 15 green marbles in the bag. Here's a reminder of one of your vocabulary words. An experiment is fair if all of its possible outcomes are equally likely. So there's 2 spinners. The spinner is equally likely to land on a 1 or a 2, so the spinner is fair. And the spinner is more likely to land on 1 than on either 2 or 3, so the spinner is not fair. Example 3, making a prediction. You and your friend play the game, so this is the spinner game that we're using here. A, is the spinner fair? B, is the game fair? C, predict the number of turns it will take for you to win. A, yes, the spinner is fair because it is equally likely to land on red, blue, or green. Now to answer B, we need to read the scoring rules. And the scoring rules say that you get 1 point when the spinner lands on blue or green. Your friend gets 1 point when the spinner lands on red. The first person to get to 10 points wins. So it says for letter B, find and compare the theoretical probabilities of the events. So for us, the probability of it landing on blue or green equals the number of blue or green sections over the total number of sections. So we have 4 blue or green sections. So there's 1, 2, 3, 4 blue or green. So if we spin the spinner, it's going to land on it's got 4 chances to land on either blue or green, and there's a total of 6 sections altogether. So that equals 2/3. And when we look at your friend's probability, they just have a probability of landing on red, and so the number of red sections over the total number of sections equals 2/6, which equals 1/3. So it is more likely that the spinner will land on blue or green than on red. Because your probability is greater, the game is not fair. Letter C says write and solve an equation using the probability of blue or green found in Part B. Let X be the number of turns it will take you to win. So we're answering the question about predicting the number of turns it will take us to win. So 2/3 is the probability of us landing on blue or green, and X is our unknown, which is how many turns it will take us, and 10 equals the number of points we need to win the game. So we simplify that and we end up with X equal to 15. So we can predict that it will take us 15 turns to win the game. Your assignment for this lesson is to complete the On Your Own problems 1 through 3 below. They are also on pages 392 to 393 in your textbook. Show your work and be prepared to share during our next class. Please remember, to earn credit for viewing this flipped lesson, you must complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for the teacher, and always have a good attitude. We'll see you next time in class.